Hello, everyone. My name is Daniel Moyer. I'm one of the energy storage trainers here at Briggs Stratton Energy Solutions. Hello, Nathan.
Hi, Daniel. I'm also a trainer here, and we're glad to have all of you with us today.
Yeah, today's topic is going to be the future of solar batteries in the grid, NEM 3.0. One thing before we get started, just want to let everybody know that the chat has been disabled, but the Q&A function is still available. So if you have any questions during the training, please go ahead and put them into the Q&A. It's usually button near the top or the bottom of your screen. Additionally, we're going to have our email at the end. This is not a NABCEP accredited course. A lot of our future ones will be. But if you have any questions or you want to get in touch with any of the sales reps, our email is going to pop up at the end. We have a couple upcoming events, right, Nathan?
Yeah, Daniel and I are both going to be at Inter Solar in February. That's held down in San Diego, and if you're in the California area or if you're planning to travel to Inter Solar, it's a great conference. We'll be there. Come see us at booth 3340. And if you do come see us at Inter Solar, we'll have a free Briggs & Stratton branded Lego kit to give to you.
Yeah, just let us know that you attended this training and we promised you such, and we'll be sure to get that to you. Additionally, we're going to be doing NABCEP. It's going to be in Reno coming up in March, and really excited. I'll be doing a training on building codes. And what are you going to be talking about, Nathan?
I'm going to be talking about integrating generators into battery and solar systems, so energy storage with generators.
Great, let's get into it. One thing I really like is our partnership with Solarc. Solarc is one of the leading hybrid inverters on the market. They incorporate all of the different parts and pieces into one box. The charge controllers, the transfer switch, the charger inverter, rapid shutdown, integrated generator support start. It's really exciting. Additionally, and we're going to talk about this, is why they're one of the best solutions with our battery for this new NEM net metering 3.0. They have some unique controllers inside that Solarc that's going to help maximize your customer savings. One thing I just wanted to make sure we cover really quickly is the basics, so we're all on the same level playing field. The heart of any energy storage system really is the inverter, that Solarc that I was just talking about. Of course, you need a reliable, high quality battery. That's where Briggs & Stratton Energy Solution comes into play. Additionally, you're going to need some great monitoring that's incorporated, all there in order to power the home's loads. This talk really is going to focus on that right-hand side, that interaction between the grid and the energy storage system. With the advent of some of these new net metering policies, we're really going to do everything in our power to not use the grid and not send any energy back to the grid. Of course, we can always add solar, and we can also add a generator to it as well. So Nathan, I wanted to show this. We show this in a lot of our slides, and this talks about the difference between partial home backup and whole home backup. Now, of course, partial home backup has been historically what we've done in the energy storage industry, and that's due to really the high cost of batteries, the less powerful inverters on the market. But now with the advent of the solar, specifically the 15K, the ability to back up the whole home, and also the ability for our batteries from Briggs & Stratton Energy Solutions to be high capacity, fast discharge at a relatively low cost, we can now back up an entire home. Now, Nathan, I wanted to bring this up is, so in a net metering policy, we want to be able to power our home without feeding solar back to the grid. And we're going to talk about what that looks like here in a second, but what we want to do is charge up our batteries during the day with solar and then discharge those batteries to home loads. Now, Nathan, what do we have to do in a partial home backup system in order for us to be able to backfeed to the main panel without sending any excess back to the grid?
Yeah, so if we want to use a partial home backup system to self-consume, right? And what Daniel's getting at here is the utilities now under NEM 3.0 don't pay much money for kilowatt hours coming back onto the grid, right? They're charging you 10, 20, 100 times, right? In some cases, what they're paying you for that electricity. So it doesn't make much sense to send your excess power back to the grid with solar. So if we put CTs and monitor the power that we are pulling from the grid, what we can do is we can set up the inverter to limit power from the grid so that we're exporting from that solar back to the grid. But really, that power from on the left side there going back to the grid is actually going into the main panel and could be consumed by the loads coming off that main panel. Those green lines that you see going down there, you could think of those as loads. That could be an air conditioning system, that could be a hot water heater system, that could be the blower motor on your fans or on your heaters, that kind of thing. So we can export the power that is being used in the main panel if we monitor it with CTs.
Thank you, Nathan. I think that's just one example of why Solarc is such a great opportunity for these net metering 3.0 systems. Just taking a step back, really, net metering, right, governs how utilities pay
Well,
solar
Daniel, if
owners.
you don't
Yeah,
mind, let's go back one slide. I just want to point out the difference here on the whole home side, right? All of your loads are already connected to the inverter. You don't have to push towards the utility or into the utility connection on the inverter. There is a 200 amp pass through there, and so the output of the inverter goes directly to the main panel. And the big difference here is we're taking the utility connection straight into that inverter. And that's because of the 200 amp pass through. With the smaller units like the 12K Solarc, you only have the 62.5 amp pass through. So you wouldn't want to put bring all of your loads through the inverter because you just can't bring enough power in many cases through the inverter to do that. And so that's the
yeah,
big difference there. And
yeah,
it's a
and the
good point
CTs
you're
are built
making.
in.
Yes. Yes. All right, let's go ahead and move on. Thank you.
Really, what it used to be, essentially net metering 1.0 or net metering 2.0, or a lot of the countries still that's on this net energy metering policy. Essentially, when you send energy back to the grid during the day, you get a credit. You get a one-to-one credit. You can then use that credit up at night. You can use that credit up in the winter. And then when you have a true up bill, it's usually on an annual, the anniversary of when you had your solar system installed, you get a true up bill. And if the solar installer that has done their job right, you will not owe the utility anything, and the utility won't owe you anything.
Yeah, it was
Whereas,
truly a one-to-one, right? It's the number of kilowatt hours that you used versus the number of kilowatt hours that you produced and sent onto the grid. And if you're at a net zero, then you wouldn't have a bill, electric bill, right? You've produced as much as you've consumed, and so you've sold that excess back to the grid that you pulled from the grid maybe in the summer or during the day.
exactly. Yeah. And now what they've switched to is what's known as a net billing tariff. So instead of giving you that one-to-one credit for every kilowatt hour you send back or consume, they're now assigning a value to that kilowatt hour whenever you inject it back into the grid. And as we're going to see coming up in a couple slides, that value, and Nathan's already alluded to, is significantly less, perhaps an order of magnitude less than what it will cost you to actually buy that. So really, with the adoption of this net metering 3.0, there's been a major shift in the economics of how solar works in California. Essentially, now you have to incorporate an energy storage system, a battery, in order to make a photovoltaic system financially viable in California. So as you see there on the right, the solar before batteries, we're injecting all of that energy into the grid during the day. And it doesn't necessarily line up with our load profile, which you see in the gray there. What we can now do is store that energy that wouldn't have otherwise been sent back to the grid and discharge it in the evening times. Of course, we're still going to use solar to provide power to the home loads that are on during the day. So with the solar only system, really homeowners have a limited ability for when they can control that power. The solar really is shining during the day, and only the loads that are on during the day are going to be offset. What we can do really by combining both solar and batteries, we can provide the biggest bill offset. So you're seeing on the right-hand side, electric only, we're going to buy everything from the grid. Solar only, we're going to be able to offset some of the daytime loads, but not the entire bill from the company. If we're able to add batteries, we can now see the greatest savings. And you will notice that we're not getting 100%. Why is that? Because there's still the cost to be interconnected to the utility, or what they've kind of people have referred to as a solar tax. And it is notable, though, even without solar, just a solar and just a Briggs & Stratton Energy Solutions battery, you can still see some returns. And that would be by having time of use, where we can store energy from the grid during the day and then discharge that battery during certain times of the day when energy is more expensive. Little history. NEM 1.0 came about in 1995, and that's about to be 30 years, Nathan. I just did the math. So we have had little bit of time to think about how this is working. And when net metering first came out, it was a one-to-one. Really, this was the impetus to get the solar photovoltaics industry off the ground and start to be able to compete with some of those larger utility companies that they were going up against. Net metering 2.0 came about in 2013. Really, there wasn't much of a difference between these two. They did have an interconnection fee. They did have some rate changes that you did have to go on to the time of use rate when you switched over. But essentially, they were the same. They were essentially kicking the can down the road, I've heard it say. So let's just take a minute so we understand net energy metering. That is, if you have a photovoltaic system on your roof, it's first going to then feed into your home, power any loads that are on at that moment, and then send it back out to the grid, and you're going to get that credit. Whenever you consume power from the grid, you're going to then pull from the grid. You got this bidirectional meter that's then going to power the home. It's a one-to-one. So the idea here is that this blue is the loads, the green is your exports, and then the kind of the yellow is your exports minus the consumption. Nathan, anything to add to this?
No, I think it's fairly clear, right? Under net energy metering, right? Essentially what you're doing is sometimes you're consuming from the grid. During the daytime, if you have solar, you're producing a little bit more than you consume, and so you're exporting, that orange Daniel pointed out. And then, as the solar drops off during the evening, and loads pick up at the end of the day, you have a little bit of export there. And then throughout the night, of course, you're pulling from the grid. And there's also a seasonal variation in this, and that in the summertime, your days are much longer. You're producing a lot more solar kilowatt hours during the summer. And typically systems would probably produce a little less and export a little less to the grid in the winter than they consumed from the grid. And so if you balance all that out perfectly under net energy metering, right, it was fairly easy to reduce your bill almost to nothing. And now with the new billing, right, things have changed. How have they changed, Daniel? What has happened in net energy metering, and is it really net energy metering anymore?
It's not. It's really net billing tariff. So as I spoke earlier about, when we inject energy into the grid, excess during the day when it's exceeding the consumption of the home loads, we now get compensated at a monetary rate. But guess what? When we consume energy from the grid, usually at night or in the evening when the sun is starting to set and the solar isn't producing, we're paying that retail rate. I would note this, that under NEM 1.0 and NEM 2.0, the homeowners were allowed to go in for a 20 years. So they were guaranteed for that 20-year rate. And we've seen a lot of people already come off NEM 1.0. There was a big push 2 years ago in April now that people were on the verge of leaving that NEM 2.0 status. A lot of people got into it so they can lock it in for 20 years. So why did the California change things? First, I want to kind of tell the story from the utilities perspective. And one of the things that they always speak about is what's known as the duck curve. Essentially, the intermittency of renewables doesn't align up with our consumption of energy. Most of the energy we consume in our homes is in the evenings when people come home from school, come home from work. And then during the day when we're gone, we're not really consuming as much. But that's essentially not what happens with photovoltaics. With photovoltaics, we're producing power during the day. And of course, when the sun sets at night, we're not producing. So on the right-hand side, what we're seeing is that duck curve. I kind of can see the duck. I hope everybody else can see it. But what it's showing is that essentially during the day in summer in California, So much solar energy was being injected into the grid that the price of electricity went negative. And that was costing the utilities money. They were having to run power plants idle or have to turn on peaker plants in the evening. They were Their story is that they were having to raise the rates on the consumers that didn't go solar in order to cover a lot of these costs. So there was a real interesting article that just came out from the Public Accountability Office that essentially says that it was costing $8.5 billion for other ratepayers to cover the costs of the photovoltaic people that did adopt it, right? The idea that only rich people could go solar, only the people that own a home can go solar. Well, there is an other side to that story, and let me break down a few of those things. That report really was debunked in a lot of ways by a new
Daniel,
study.
before you
Yeah,
go into that much, let's add a couple of things from the utilities perspective, right? If you're a manufacturer and you have a machine in your possession, right, that you're wanting to operate, and let's suppose it makes something very simple like screws. You feed in raw metal input and the machine produces screws. You really want that thing running. You've invested a lot of money. You're probably paying interest on a loan you took to get that machine, and you want it running stable, consistently, 24 hours a day, right? And so you'll probably end up paying workers at nighttime to be there, and you want to get the most out of your investment because the investment itself cost a lot of money to get, and you might be paying an interest on it. Well, publicly owned utilities like those in California, whether it's Pacific Coast Gas and Electric or the San Diego, their power plants, I'm blanking on the name there, but these investment-owned utilities want to be selling electricity, and they want to be running their plants as efficiently as possible. And that means not starting them up and running them and ramping down the rate when demand goes down and solar production goes up. They want to run those consistently. And one of the things that the utilities in the United States have to do is have all of these old plants kind of on backup, waiting for that peak demand to kick in the evening, just when solar is starting not to produce anymore, right? People come home from work at the end of the day, the solar is not really there, and they're turning on all these devices. And so the utilities, the easy time for them to sell, solar is there to take that demand. And so there are some things that change this, and the biggest thing changing it is batteries. And I know you're going to be talking about it. And yes, there are two sides, of course, to this story, and then I'll let you get into that other side. But it is true that the demand, having people use, and you and I have used this term, having people use the grid as their battery. During the summer, they send all their excess energy to the grid, and during the winter, they pull, right? It was not entirely fair to everybody else who uses that same grid, because those people that are not taking advantage of solar end up footing a bigger portion of the bill.
I think that's a great point, Nathan, that there is.
I think it
Yeah,
might have swung a little too far, and I think you're going to get into it. And I think everybody's going to see this when they also see the rates that the utility is paying people back for feeding into the grid. But
no,
let's
I
hear what
think you're
you've got on
absolutely
this
right,
slide.
Nathan. There has to be a balanced approach, right? We do understand the physics of how our electrical grid works, and we can't just have people using the grid as their battery. I will say this, that they could have done it at a more ramped down rate and not have what's known as the solar cliff.
Yes.
One of the things that they came up with, that insane amount, right, is that they were assuming that the electricity that the homeowner produces, right, is counting against their costs. In other words, if I say go to my house and I add insulation or I put in LED lights, is the amount of energy that I save, do I owe that to the utility? Or maybe if I start up my own screw factory in my house, do I owe that company the lost revenue? It's not necessarily a fair comparison, and
Sure.
it shouldn't be counted against the cost to all the other utilities. If I grow some vegetables in my yard, I own those vegetables just like I own the electricity that my solar produces as well. Really, we need more generation, not less. And one of the big problems with a lot of the solar photovoltaic installer companies in California is if you're not seeing the solar payback, people aren't buying solar. And if you're not really installing solar, really it's hurting the battery industry as well. I think their argument doesn't acknowledge the decarbonization of our energy and give value to that that portion of it. I'm afraid that other states that haven't reached that solar saturation point will adopt and replicate what California is doing before they get to that point, jeopardizing the ability of that state's decarbonization policies. Already mentioned we don't have a solar cliff, right? We needed a more of a ramp down approach to that. There's a great article there. I'll leave this link. Everybody's going to get a recording and a copy of this slide deck at the end so you can read a little bit deeper into this and make your own opinions.
So one of the things about producing electricity as a utility is it's always been intermittent. There's always been more demand for electricity during the daytime than the nighttime. And one of the balancing things for that is having factories, right, kind of level out and buy that load during the day when consumers aren't at home and aren't running their electric ovens and their air conditioning system because they're outside of the house. What we haven't noted yet, and what is becoming more and more the case, is that these high costs that the utilities are imposing and the rapidly dropping costs of solar and now battery systems has meant to more and more traditional customers of the utility, big places like universities and like factories and Google, Apple, they are going to microgrids in the same way that we are seeing people defect from the grid because it now has become so cheap to produce electricity with solar. I mean, the cost of solar in the last decade has dropped probably 50, 60%, right? And in the 20 years that I've been in the solar industry, it's dropped by 1,000%. It used to be $2.50 to buy a solar panel per watt. Now it's 25 cents per watt on some of the retail, right? And so the costs have rapidly come down, and there's a big question as to what happens to the grid. Microgrids are interacting with the grid and really only using the grid for the balance of power that they can't generate. And I think there's a real big question of what happens to utilities if they don't get this formula right.
And I think they would be also responsible. I see and envision, and of course, we sell residential batteries and some commercial batteries, Nathan, but the idea that also a utility scale energy storage systems, flywheels, pumped hydro as well, could also contribute to the stability of the grid. What we're looking at here on the screen is kind of a breakdown of the different net metering rates as they went across, right? NEM 1.0, 2.0, and then now net billing tariff. Your import rate really could have been anyone under net metering 1.0. Time of use rates were implemented in NEM 2.0. And there's also more of a specific electrification time of use rates now. I do want to jump down a little bit and just mention that the import rates, the credits for energy exports before the true up, right? You would be able to pay the same price as whatever you would import it now. Then now if we look here, what we're seeing is that it's the price of the whatever the avoided cost would be. What would it cost for that utility to produce that electricity is now what they're going to compensate you at now. Of course, what didn't change is that if your true up exceeded, right, if you produce more than you consumed over that year, you would get credited back at the wholesale rate, which I think is fair, and that's what it continues to be. There is, of course, the 9 non-bypassable charges. That's kind of the solar tax or the fee just to be connected to the grid. Another thing that report didn't include is that solar consumers with batteries are still paying something to the grid to be connected to it as well. I think the billing true-up period was interesting with the new net billing tariff. You now get trued up monthly, not annually like I talked about before, but you can roll those over. Additionally, they have now kind of opened it up. If you look at the installation size limit, I'm at the bottom of the chart now. Here, what it says is that really you could only install a photovoltaic system the size that would offset your loads. Now, what you can do is you can go about 50% bigger if the customer says, I plan on getting an electric car. I plan on getting a heat pump. So it does give you the ability to oversize that system a little bit as we go into that. I really like Home Power Magazine. If anybody ever read a Home Power Magazine, it's a great publication. And like most magazines, they've gone out of print. But the idea that we've been thinking about how photovoltaics, how renewables interact with the grid is not a new thing. And I chose two of these articles here that coincided with the advent of NEM 1.0 and NEM 2.0. And again, these are all linked. Home Power is still available in archives online, and we can go in there and look at that. The idea again, though, and Nathan hit upon it also, the seasonality, but the daily, right? So now we have this blue here, which is essentially our home during the day being powered by the photovoltaics. The green here is what we're exporting out to the grid, and we're under the older net metering policies, we would get that one-to-one credit. The red here is what we're consuming from the grid. With this new advent of net billing tariff, what we need to do now is store the green in batteries and then discharge it in the red so we can see that financial payback. There is seasonal variations, and unfortunately, you can't have a battery big enough to store production during the summer to then discharge it during the winter. I would say now Nathan and I live a little bit closer to the coast, so we don't have air conditioning loads, but that could be a benefit as well, where we can run the air conditioner using some smart load devices. Maybe it's even the thermostat where we can adjust those thermostats, those hot water heaters, some of those other devices, so that we're trying to coincide the consumption of the production variations and then do everything we can to avoid purchasing from the grid as well.
And to give people an idea, the solar systems that Daniel and I have out here and that get installed around us, and this is going to vary depending on where you are in the country. It partly varies based on the number of hours in your day, but it also varies based on the weather, right? And so Daniel and I have a rainy season that's just starting out here in California, so we get a lot more cloud cover. And we have shorter days in the winter. So production-wise, to give you an idea of how much different it is, it's about 50%. So the number of kilowatt hours I'll generate on a January month compared to the number of kilowatt hours I'll do in a June month is about half. So it's a big drop in the amount of production you get in the winter for us and for most people, just based on the fact that your daylight hours are much shorter. Right? And the farther north you go, the bigger variation you get. And then the tilt of your solar array towards the south also, influence it as well. In Alaska, you're going to tilt your panels way south because the sun is very low in the sky. So a lot of things go into this, but it's very common to have half the produced number of kilowatt hours in a winter month than you do in a summer month.
One thing I really want to talk about is this whole net billing tariff could have been worse if it wasn't for some of the great lobbying work that California Solar and Storage Association did. If you're not a member, I encourage you to join. On the California Solar and Storage Association's webpage, there's a members only resource page, which has a lot of breakdowns of some of these decisions that come along with it, some of these export rates, which is actually what you're seeing on the screen here. Additionally, they have help if you ever have permitting issues. They have a permitting hotline that can help you out. It's a great, and if you're not located in California, there are associations, I think I said that twice there, Nathan, that you can join, and these groups are out there working for us. So Nathan, what are we looking at here on this heat map?
Yeah, so just so everybody knows what we're looking at. So I second Daniel's point about the fact that CALSA does a lot and provides a lot of resources in that members only section. It is important to be part of those groups because lobby on behalf of large corporations, investor-owned corporations, right? There's a lot of power behind that, and if consumers don't get together through associations like CALSA, it's very hard to adequately represent consumers. So what we're looking at on the screen here is the amount of money that you would get credited. So remember, net billing tariffs for excess electricity that you generate and send back to the grid. And so to give a rough idea, Daniel and I pay approximately 50 cents per kilowatt hour for electricity that we buy. And you can see that if we go to December and look in the month of December around the hour of 10 o'clock like it is, I am currently buying electricity at 50 cents a kilowatt hour. And if I were to sell electricity back to the grid, they would compensate me at $0.048 or 4.8 cents per kilowatt hour. So it is a factor of 10 difference. Now, there are some times highlighted in green,
Yeah.
right, where you can sell back to the grid and get a lot more than what you're paying. In fact, just a couple of hours of days during the month of September, we can get a few dollars, $2 to $3 per kilowatt hour that we send back. But the red portions of the screen where Daniel's highlighting, excess electricity sold to the grid during the hours of the day when solar is producing, it's as little as $0.001 or a tenth of a cent, right, at the minimum. But many of those numbers are just a cent per kilowatt hour that you sell back when you sell back to the grid. So quite low.
Yeah, it should be noted that these aren't set in stone and these will change year to year. It should also be noted that those green is in the evening. That's right, 7 o'clock, 8 o'clock there.
In
One,
September.
yeah,
So it's very likely your solar is going to be producing. What would we do, Daniel?
one thing we can do is if we've charged the batteries up from solar, we can discharge the batteries to grid. And this is where Solarc and Briggs and Stratton Energy Solutions really come into play. There are controllers inside of that Solarc, and Nathan has done some other great talks where we dive a little deeper into some of these settings. We're really just going to kind of brush the surface here for a second. During August, September, from 6 to 8, like we identified on that last slide there, that value is significantly more, right, than even what you would be purchasing. So what we can do is we can program in the early mornings of August and September, the battery is discharged, right? And then we're going to charge it up with solar during the day. That evening between 6 and 8, the battery is going to then sell back to the grid, maximizing some of those credits. Then at night, we're going to stop and we're going to make sure that battery is maintained by the grid so that if you do happen to have an outage at night, you're still going to have a little bit of a backup power as well. Anything to add?
Well, no, I think that was a good description. What you're looking at is the utilization of grid cell. The limited power to the home box is checked there. But if we are selling back to the grid, that's assuming we've already covered the loads in the home, right? So we're going to push excess power until the batteries drop down to 5%. And those are the time of use settings that are there. In Solarc, you can also program seasonality into
Yeah.
your inverter, and we're not showing that there, but if you click that setup box, you can program seasons. And so, you can program to sell to the grid during those hours. We do on that screen, and we're showing a checkbox under charge to bring it back up from the grid as well. And so you do want to be careful that you're buying from the grid. If you are using a battery, that you're buying from the grid at the cheaper times, that the electricity rates are lower. And we have variable rates here in California. We have peak demand rates and we have off-peak rates, and that you pay about 5 cents more during peak times here.
Yeah, and that's a great point. We wouldn't want to be sending back to the grid during some of those other months of the year because we wouldn't see that financial
Right, you would
return.
want to self-consume, right? And that's where the seasonality of the Solarc, where you program in your use of your battery, you can avoid some of the high cost electricity, and you can choose when to self-consume your electricity from your batteries.
I do want to encourage everybody on this call to put into the Q&A. What are your thoughts about this new net metering? Have you done something similar to what we're showing on this screen? Any questions, please put them in. It always makes these talk a little more interesting. If you're thinking of the question, chances are somebody else is. Nathan and I will be happy to answer them. For a moment, Nathan, I want to take the battery out of the equation. That's a little tough because we sell batteries, but should your photovoltaic system face west with this new net billing tariff? And Aurora Solar, which is a solar proposal tool, modeling tool, and finance tool, they do a lot of things in addition to Open Solar that does very similar things. They had come out with this article. And again, what we're seeing here is this This black line here is our solar production, and this dashed blue line is our solar consumption, right? Production, consumption. And what we're doing here is we're talking about the value of what we're exporting. So this like kind of dark blue here, that's what we're self-consuming in the home from solar. The light blue is what we're exporting. And then this pinkish color right here is essentially what we're self-consuming during those peak hours. And it's a little hard to see, but there's this little sliver right here of what we're exporting during peak hours. And the argument is that with this time of use rates, which you're forced onto when you go onto these new net metering policies, that it's better to face your solar panels to the west, specifically the southwest, so that we shift our production curve to better align with our consumption curve. Essentially, the value of our self-consumption during these net metering is worth more than us sending it back to the grid. All of this right here is worth very little, remember, because we're net billing tariff. But if we can self-consume later into the evening to help produce, to help offset some of those costs, it's financially better. Now, I understand that not everybody's roof is oriented in this way. There may be trees that impact this, but using some of these powerful proposal tools from Aurora and Open Solar, just don't make those assumptions and model it out. Do a different couple of proposals, and you'll get some great feedback from some of these tools.
Yeah, that's a great point, Daniel. I think that the software that's out now is so good. It helps you accurately model how that solar and that return on investment is going to be. So what Daniel was saying about having a west-facing array, that power from that west-facing array can keep your batteries topped off longer into the evening so that you're consuming that solar power as it's being produced. And then your batteries are there to last throughout the night. Versus if you don't have a west-facing array, you just have maybe a south-facing array, your solar production is going to end sooner. You're going to have to start dipping into your batteries sooner in the evening. And, maybe by morning time, you won't have any batteries left and you'll have to be buying from the grid again.
These Aurora and Open Solar have done a great job of importing all of those rates. If you notice on that chart, there was a different value of electricity for every hour of every day of the year. These companies have been able to import that to accurately model this. So when you are sitting down at the kitchen table with the homeowner, you can be confident in what you're proposing to them for the payback period. Another way to think of this is also using load shedding devices. Lumen, Span, Savant, they're coming out with products that allow you to not necessarily shift the production curve to better align the consumption curve, but you actually shift the consumption curve to better align with the production curve. I think of maybe a hot water heater, Nathan, where we can turn the hot water heater on during the day, an electric hot water heater, make a bunch of hot water. That tank is pretty well insulated. It's probably one of the cheapest batteries, a thermal battery you could have, and then have hot water later into the evening. Of course, you can always turn it on if the temperature drops too low, maybe just do the top element. There's other ways to do this. So the idea that you can also adjust the consumption curve to better align with the production curve is available to some of these companies. California Solar and Storage Association, again, if you haven't joined, I would consider joining today. That QR code that you see on the screen takes you to that login. It's not as much money as you might think, and it's based on the size of your company to be a partner with that. One thing I found on their webpage is some of the FAQs. So say somebody has a home and they're on nobody's on net metering 1.0 anymore, that's ended, but if they're on net metering 2.0, they sell the home. Does the new owners of the home have to be switched to NEM 3.0? No, they don't. And that was thanks to this great FAQ, right? They has no impact in whatever the remaining years left. Say had 8 years on that solar. Remember, it's a 20 years. They would get 12 years left over on that. Can I add a battery to somebody that's on a NEM 1.0 or NEM 2.0? Yes, you can. You can add without altering that status. Another big question I get a lot of times is, can I add more solar panels to a net metering 2.0 and stay on that favorable rate? And yes, you can. You have to be a little careful. So say if I have an 8,000 watt inverter and I have 8,000 watts of solar panels, if I add extra solar panels, I don't lose that. Now you might be thinking, well, why would that be? Why would you even want to do that? It's because during the mornings and in the evenings when the sun isn't is not hitting those panels directly or not as much insulation, you're going to be able to get closer to that threshold of that solar inverter. If you
And that's
only had,
called inverter clipping, right? Where
yeah,
it's
yeah.
actually sending more power to the inverter than the inverter can produce. So the inverter uses what it can and it maxes out at its max value. Typically, this is a amperage limitation of the inverter, an amperage AC that it'll send back to the grid. I can tell you that, putting a 7,500 watt solar system on your roof, you're almost never going to see 7,500 watts. But if you've got a 7,500 watt solar system on your roof and an 8,000 watt inverter, you might add 2, 3, 4,000 watts of solar to that inverter and see a good return on investment. And that's for what Daniel said. You're going to start saturating that inverter and having it produce 8,000 watts earlier in the day and longer into the evening, which means you're getting more of your NEM 2.0 credits back, right? So that you can utilize them later in the year or during the nighttime.
And exactly what we talked about earlier, Nathan,
What
is
if you
that now
change
we're
the inverter, Daniel? What if you need to change the inverter? Can you still stay on NEM 2.0?
if believe it's if this nameplate capacity, if you start to increase that stuff, it could drop you off.
Okay.
There's different types of net metering, and this was a big contentious issue, right? So if you just own a home, it's net metering, right? It's just on the property. There's other ways to do what's known as meter aggregation, and that's the idea that say you have a barn that has a separate meter and you have a home that has its own separate meter. The barn might be the best place to put solar. It's out in a field, there's no trees, and it just got a big huge roof. The idea that you could put solar on the barn and then have the solar on backfeeding one meter and then apply those credits to both of the meters, that used to be the idea. Or if you have adjacent properties where the properties touch each other, that was allowed. There has been some changes now where you're not necessarily able to transfer over all those credits. So it is a big problem. California Solar and Storage Association has some more resources on that. I think virtual community solar. I think of this, Nathan, is that I have maybe an electric car, but I drive to work, and my solar is on my home. Why shouldn't I be able to necessarily pay a little for the grid to use that energy to have a charging station at work, charge up my car with the solar produced from my home? Any thoughts on this, Nathan?
Well, it's you make a great point, right? Where electricity is produced now is not just from the utilities anymore. It's not just those big turbines that those utilities are making electricity, and that is essentially what microgrids are. And I do think that we will see a growing microgrid movement over this next decade. I mean, I think we're in the middle of it now, where companies have realized that they can benefit by having their own microgrid, using the utility to, using essentially the power lines that the utility owns to transmit that electricity. We're really, as consumers, at the mercy of the utility to do that. And currently, to my knowledge, there are no programs out there that allow you kind of credits to your work from what you're
Yeah.
consuming, you're producing at your home. I will tell you that, 3 months ago, I finally bought an electric car, and I plan to try to put solar and charge my car during the day. And I think electric vehicles are going to not only put a strain on the grid, right, but also necessitate the need for more changes coming down the pipeline, right? If more and more consumers are using these electric charging stations, well, more and more consumption is going to occur during the daytime, right, when solar is available. And so it does lend well. Electric vehicles lend well to charging at work or at the home from solar. The other side of that is that traditionally electricity producers, the utilities, are making electricity during the daytime and then have to shut their plants down at night. My example of that screw factory is a good example. They have to rapidly decrease the production that the plants could be doing during the night, and electric vehicles could be programmed to provide that load that utilities want at nighttime to kind of balance out, and then the utilities wouldn't have to have such varied resources. There are a lot of old plants in the US that are kept online simply for when peak demand hits and the utilities have to ramp up production in the evening time. So
Yep.
stabilizing the draw from the grid will be helpful to utilities and to consumers alike.
Yeah, so I guess the point here of this slide is not only is the rate at which you're being compensated for excess solar sent to the grid matter, but also the ability for how net metering works, whether you can aggregate or virtual power plants as well. So I want to give credit to Josh Brum for this slide. He kind of talked about this. So say we are sitting down at the kitchen table and we're talking about this. He kind of would put NEM 3.0 customers into 3 buckets, right? Right out of the gate, we're going to assume that they're going to need storage to make this. And ask them, how often do you have power outages? How do you envision this work for you? What kind of budgets? Then listen, trying to determine what kind of bucket they fall into, and then they can always move around. So bucket number 1 really is somebody that's not worried about outages, maybe live in the city, they don't really have any medical devices or anything that's going to go offline. What we're going to do with them really is we're going to put in a relatively small battery system and maybe a very small photovoltaic system and just focus on the return on investment. We don't need to put a photovoltaic system that offsets their entire annual usage, because it's not really all that excess going to the grid in summer isn't going to make them any money. So kind of the old paradigm of us thinking we need to look at how many kilowatt hours they use a year, produce a solar photovoltaic system that's going to produce that and then offset. We can't do that anymore. So the idea here, what we're going to do is just look at how much energy they use for their nighttime loads, size the battery system for that, and size the photovoltaic system for that so that it'll charge up the battery during the day and then start discharging that battery at night. Bucket number 2. This is somebody that still wants that fast return on investment, but they do want a little more backup power, the ability to weather some of those storms. What we'll do in this example, right, we're going to look at what's their daytime loads and then subtract that from the production. So what I mean by that is, remember we talked about how the solar is going to be able to power the home loads during the day. Let's just look at what that excess is going to be and then be able to store that into a battery and then discharge that to help get them through the day. Bucket number 3, this is somebody that, of course, wants a return on investment, but they're willing to spend more money and they're not that concerned on it. Really, they want the off-grid capability of an on-grid home, the quote-unquote, I hate the utility person. So in that case, what we're going to have to do is look at how many kilowatt hours they use on the worst day of the year. Probably during the winter, unless they have large air conditioner loads. So no averaging. Figure out the maximum kilowatt hours they use on that worst day of the year and then size the battery and the solar accordingly. Essentially, we're going to be able to off-grid them during the day or night during the winter when the loads are probably going to be the greatest. Nathan, how do you feel about the buckets or anything to add?
Yeah, I would say that, the cost of bucket number 3 is rapidly dropped.
Yeah.
The price to actually have enough capacity to run without the grid for days at a time now is not as much as it used to be. And I think that you will see more and more customers choosing that bucket. But cost is still a factor, and having the upfront capital to do bucket number 3 is sometimes cost prohibitive for customers. Now, there are solar loans out there that are available. Most customers, think that they want to be in bucket 3 and often move down to bucket number 2, where they'll do kind of a hybrid system. They'll do, their solar and their batteries for a good fraction, maybe 2/3 of their electric use, giving a decent amount of backup time in a grid outage. There are a lot of benefits to this. but
Yeah.
then using that grid for the extra that they need to get. And so I think from a cost standpoint, the greatest returns on investment might still be in bucket number two.
Yeah.
But I think bucket number three is becoming more and more attractive to people that are fed up with utility prices and practices.
Yeah, exactly. And I know
Myself being one of them.
we're running out of, we only have 11 minutes, so I want to
Yep.
keep going on. The reason you're not going to see the big return on investment because bucket number three is because it's oversized for summer. And
Right.
you're once the batteries are full, the loads are satisfied, you're going to start exporting and you're not going to get anything for it.
Right. Yeah, and that's an important point. So if you can buy a bit of electricity during the winter time, it probably makes more sense to choose bucket number two at this time.
We do have some packages. I'm not going to say these exactly correlate to what these buckets are, but it's just an idea of to give you a sense of what it is. And again, you can always add batteries to these systems, but we have the Solarc 8K with the one stack of our 6.6 batteries in the middle of 12K with the two stack. And on the right-hand side is that Solarc 15K with the three stack, just under 20 kilowatt hours. Really excited about that package because it offers that 200 amp pass through. That one stack is enough to power that inverter if it's called upon to output its max power output. So it's a really exciting. Again, these aren't necessarily going to correlate to those buckets, just an idea of what we're looking at. Nathan, what are we looking at here?
On the left, we're seeing a floor-mounted Briggs & Stratton 6.6 three-stack of batteries paired with a Solarc 15K. This is a marketing image. Those aren't quite the right conduit connections, but it gives you a rough idea of what it would look like. And we're looking at our stackable battery. And what I like about this battery, I've installed a lot of our batteries, and what I like about this battery is how quickly I can install this battery. Right. I like the fact that it's an outdoor rated battery. It's wall mountable if you want to do that. So we can use this battery outside. It'll charge down to 15 degrees Fahrenheit, right? 14 degrees Fahrenheit, I believe
14,
it is. Yeah, a low temperature charge. So that's nice. I like the status lights that are on this battery as well. You know, a lot of companies are choosing to put some type of display, and it does give you an idea. You know, the status LEDs there let us know that the batteries are functioning normally, and there's a fuel gauge on the top. And then what Briggs & Stratton has come to the market with here is this, you see those gold-plated connectors there that's transmitting not just the power from battery module to battery module, but also the communication. So it's truly a wireless battery. The only cabling that you'll have to use is the kind of final connection between the battery and the inverter for the comms and then the power. We're looking
one
at
thing, Nathan, is
yeah,
right. So when we're talking, this talk was talking about using a battery not just as a backup, but really a grid interactive appliance, I would say, in a lot of ways. And one of the worries I get about people is, how many cycle lives does it have? But Nathan, yeah, I didn't want to interrupt you there, but
well, it's okay.
you
It's
can
just, I mean, I
cycle
think
this,
that
right?
you're saying it well, and that, cycles matter. So if you are trying to do a grid interactive battery, you're going to be cycling 365 times a year, or something approximately like that. And this battery, even with 100% depth of discharge, at a very high rate in the lab, we're looking at 4,500 plus cycles. Most customers are not going to be discharging at, in an hour and 20 minutes, or even in a 2-hour window. So if you're discharging a little bit slower, it's easier on the battery, and you're getting more than 6,000 cycles out of this battery. So a typical discharge for a customer is more like a 0.1 C. So you're discharging over 10 hours or 12 hours. So you're looking at 6,000 cycles. So you divide 6,000 by 365 times, you're going to get a lot of years out of this battery.
16 years. And that's a kind of a new thing for me, Nathan. I always considered the health of the battery on the depth of discharge, but with these new lithium iron phosphate batteries that are safe, last a long time, really it's the rate at which you're charging and discharging them that can affect the battery life more. And Nathan, I know you're an old physics professor at Cal Poly, so I think it would be great in some of our future talks where we can break down some of the physics behind why that is. Nathan mentioned it is outdoor and indoor rated, which I think is great. It looks like a great battery. We're running up on time, so I don't want to spend too much on this slide. Just know that, again, The cycle life is there to do what we're talking about with this NEM 3.0. We do have an end of life capacity of 75% of retained energy capacity at the end of our 10 years. We do have that wider temperature operating range that allows us to put these batteries into certain locations outside that
Yeah,
weren't
we
always
can
available.
discharge this battery all the way down to -4 degrees Fahrenheit and all the way up to 131 degrees Fahrenheit. So, you'll have a little bit of curtailment. It might slow down the rate at which, but you can still get a decent amount of power out of this battery all the way down to -4 Fahrenheit. So a very broad temperature range that we're offering here. It's
Little over,
suitable.
yep. Yeah, thank you,
Yep.
Nathan. Yeah, a little over 2 feet wide. We do need a base at the bottom. We either offer a floor base or a wall base, and then we have that controller up top. Each battery is about 135 pounds, and I've seen Nathan stack them by himself. We do have other batteries still available. Notably, we still offer a 24-volt lithium iron phosphate battery, or Phi. And this is a non-communicating battery, which is totally acceptable in some older lead acid battery replacements, or maybe you have some old trace inverters or Xantrax or whatever the case, where those inverters, those charge controllers don't have closed loop comms. Go ahead and get a battery that doesn't have that. You're not paying for something you don't need. And we have integration guides that tell you how to program that charge controller, how to program that inverter to treat the battery correctly. Additionally, the amplified battery that you see kind of in the center left, that battery is really great at scaling up. We can scale these up pretty large to meet the power and energy demands of larger systems. Of course, really excited about our 6.6 battery that's quick install, outdoor rated. We also offer high voltage modules as well that can power some of the 208 three-phase or 480 three-phase as well. I know we're running short on time, Nathan, so I don't want to spend too much time, but let's talk us through really quickly. Why is it so easy to have two stacks of batteries, two stacks of 6.6 with one solar?
Well, one of the Solar 15Ks, they were actually showing as 12K there on the screen. So the
Yeah.
15Ks do come with two battery inputs. So the picture on the far right side of your screen shows there are two independent 200 amp 48 volt breakers that are there to bring battery power in. So if you're providing two battery stacks, it's a really common configuration with one Solar 15K to give you a lot of backup time for your house. You don't need an additional combiner, so it saves you some on the cost. And then you do want to, if you want to use the full power output of a Solar 15K, you will want to use both battery inputs. So if you want to do that with a single set of cables coming from a single stack, you'll want to use those combiner bars that Briggs & Stratton manufactures.
It is well mountable. One of these batteries just went through an earthquake up where I live, and it's still holding to the wall. I think this, what you're looking at here is just a diagram of how it installs to the wall. I think a lot of this speaks to the engineering that Briggs & Stratton put into this. Not only the cell construction, the battery management systems, the controller, the software, but also just the physical structure of how it connects to the wall.
Yeah, you have a very a rugged racking that the battery attaches to, a strong system there attaching that battery to the wall, to the floor. And then that all gets covered up to give that nice floating look that you see.
That's the conduit on the top. Again, we're running out of time. Please put any questions you might have into the Q&A. Really, we're going to leave just a couple minutes here at the very end.
Yeah, I think let's
Communication.
just go ahead
Yeah.
and pass through this one, Daniel. The communications connections to the Solar are fairly easy to do.
Yeah.
We also manufacture a whole line of generators suited for the home. And one of the things you can do with a battery system is combine generators and batteries so that you get more of a hybrid type approach. You're not running that generator and burning fuel, expensive fuel, as long if you have batteries. But if you are in a place that gives common grid outages, you can combine one of those air-cooled generators. On the right side of the screen, you're also looking at our commercial line of liquid-cooled generators. And of course, Briggs & Stratton manufactures some great transfer switches that have the ability to do load shedding as well.
Yep. And 18 and 22K in the middle, those have NG max where they don't derate when you run them on NG. Another thing, we're really quickly, Nathan, we're talking about the stability of the grid. Briggs & Stratton generators are also able to participate in demand response programs where if the demand on the grid exceeds a certain threshold, the utility can actually send a command to the meter, I think, to turn the home power off. And as far as the generator and transfer switch are concerned, they'll just start up. I don't believe that's necessarily available in California, but it's just another example of how not only energy storage, but generators can help participate in the stability of the grid. If
And
you
the
are,
utility
yeah,
will compensate that homeowner
substantially, yeah.
substantially for off-gridding during those times where the utility needs to shed demand. Daniel, I want to point out here that if we have installers on this call, and they have not installed a Briggs & Stratton energy storage system yet, that you can get $1,000 off your first system. And if you're interested in joining our Elite Installer program, if Daniel can help you get signed up for that, we'll get you on our map. That'll help us have a place to send customers that are looking for an installer. Additionally, we reward our installers that are part of this program by offering them a $100 rebate on each of the batteries that they purchase through us. So you'll get checks quarterly for that. So our email is on the screen. Our phone number is there as well. If you have additional questions, you can submit them now in the Q&A. We'll stay on an extra couple of minutes here if you have questions. Email there is energystoragetraining@basco.com, briggsandstrattoncompany.com.
If you're coming to InterSolar, coming to NAPSEP, let us know when you get there, and we'll be sure to have a gift for you, one of those Lego kits. Nathan, I do see one question.
Yep. Has there been consideration of using mining pools for Bitcoin Monero to monetize curtailed power or divert power flow during periods of low grid feed-in rates? I would not be the one to be able to answer that question. I'm not sure. I wouldn't be surprised if having loads in the nighttime. But I'm not sure if that equipment also needs to run 24 hours in order to get a return on investment with it as well. Daniel, do you know much about mining?
No, I don't, but I was also hearing about how the advent of AI is starting to increase the consumption of energy for a lot of these data centers. So a great point, the idea maybe that you could compensate these companies for reducing their consumption during certain times.
Yes, I do think that we will see kind of a lot of changes to evening out the consumption from the grid. Mark asks, do you need the transfer switch with the battery, or does the controller do it? And the answer to that, Daniel, is
yeah, and it's a microgrid relay, and I've heard we kind of just call it a transfer switch inside the Solarc, but technically it's not a transfer.
Yeah, so
it achieves
clear,
the same
Mark,
function.
the answer is no. You don't need the transfer switch to use an inverter-based system. The inverter will connect and disconnect from the grid. And that's what Daniel was talking about, the fact that the inverter has that micro interconnect device. It's really a relay system inside the inverter to switch between different power sources. And it
switches pretty fast, right, Nathan?
Yeah, just on the order of milliseconds, right? So it's 1/200th of a second, I believe, is 5 milliseconds, I think, is what Solarc advertises as the transfer. So it's unlike generators, it's almost instantaneous. And yes, you can bring up to 80 amps from a generator, Mark, into a Solarc. So on the generator port, you can bring 80 amps continuously through the gen port. You can also bring a generator in through the grid port using a transfer switch. I'm assisting an installer here today that's doing a couple of paralleled inverters, and we'll be bringing the generator in through the grid port there because he's an off-grid system. So yes, you can bring a generator straight into a Solarc, and I will be doing talks on that at NABCEP. And Daniel and I have done talks in the past about generator integration. So please check our YouTube channel if you want to get a little bit more information of how to hook up that.
And not only how to, but also how to program it. We can adjust the start percentage of the batteries as well. So Nathan, thank you. We do have one more talk this week before we take a break for the holiday. We're going to be talking about how to sell. What kind of strategies, techniques do you need when you're sitting at the kitchen table?
So, and the point of that talk is to contribute. Yeah, so our YouTube channel is Briggs & Stratton Energy Solutions. Daniel will be sending out a link that will take you to a recording of this video, and you'll be able to access other talks by subscribing to that YouTube channel, or at least just checking the other posted videos that we have there.
Thank you, Nathan. And if we don't see everybody before the holidays, Merry Christmas, Happy New Year, and we'll see everybody next time.
All right, thank you, everybody. Happy holidays.